Okay, so the recording is going now, 13 minutes late, but all we've so far discussed is what we're doing for the midterm corrections, which again, I will compose in an email and send it to everyone, okay? So now let's go ahead and get to the homework. So we started talking about functions. Functions, as we saw, have a lot of correspondence with regular equations that we've dealt with. So who has questions? What can we go over that you guys were confused about? Anything in particular? If not, then the domain questions are ones that probably come to mind. 27. Yeah, sure, we can do 27. Okay, so and Keji for 20, sure, we'll do 20 just a second. Okay, so for 15 through 27, which also includes Keji's question, the idea here is we're just trying to figure out whether y can be written as a function of x. What does that mean? Well, that means that if we solve for y and we get y is equal to blah, 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 right, something, can we replace y with f of x is equal to that same, whatever it is? That's the heart of this question. Can we do this? Okay, so it's up to us to see if it's possible. So for 27, let's take a look. 27, we're given x squared plus y cubed is equal to 5. Okay, so once again, we have to solve for y. That's our general first step here to figuring out whether or not we can put it into functional notation. Okay, so solving for y. All right. Let's see here. Amanda, I haven't called on you in a while for a question. Help me out. What's my first step for solving for y?
I'm not sure.
Okay, so what do we have here? We have x squared plus y cubed, right? And we're trying to solve for just the y, right? So if we have an addition of some piece that we don't care about, how do we undo addition?
Subtraction.
Subtraction. Yeah, exactly, right? So what we're going to do is we're just going to subtract over the piece that we don't care about. We care about the y. We're solving for y. So let's move over the x squared. So I'm going to subtract x squared from both sides. So subtracting x squared from both sides, I'm left with y cubed is equal to 5 minus x squared. And if you wrote it as negative x squared plus 5, that's totally acceptable. We know that it's commutative. That's totally okay. So either way, however you wrote it, but the point is that y cubed is now by itself. Okay, Ashley, if you can help me out, we see that we have y, but it's to an exponent, right? How do we get rid of an exponent? Again, I'm trying to solve for just the y, so I want to get rid of that y cubed. Well, I want to get rid of the cube.
With a square root?
Okay, very nearly close, right? We know that it's going to be some kind of root, but is it going to be a square root? Remember, square indicates that the index would be a 2, right? But we want it to cancel with the cube. So what's that index going to be?
So it'd be the cubed root?
Cube root, perfect. Yeah, exactly, right? We're going to take the cube root of both sides, and the cube root, we're doing this because we know that if we take the cube root of a cube, well, we're just going to be left with just this piece, just that y. So we know that the cube root is going to cancel with the cube. So perfect, we're now just left with y over here. And on the right-hand side, we're left with the cube root of 5 minus x squared. And now this is the part where you have to ask yourself, is this a function? You have to ask, is this going to break any of the rules that we talked about, in the lecture video regarding functions? So the biggest telltale sign, whether or not this is or is not a function, is whether or not plugging in x, plugging in a value for x, is going to give you two different answers for y. And in general, that generally means that you're going to have a plus or a minus somewhere in there. Well, when we take the cube root of both sides, and anybody can answer this, when we take the cube root of both sides, do we have to include a plus or minus? Another way to think about it is we know we have to include a plus or minus when we take the square root, but do we have to put a plus or minus when we take the cube root? Yeah, Grace. Grace said no, right? And that's correct. We do not have to put a plus or minus. And the reason that we don't is because when we take the cube root of anything, doesn't matter what the sign is, the sign will always, that sign will stay the same, right? Just for a quick example, just a quick demonstration, if you take the cube root of positive 8, you know you're going to get a positive 2. And if you take the cube root of negative 8, you know you're going to get a negative 2, right? And again, it just means that your sign is going to remain consistent. You're not going to have two different possibilities that are going to, arise from taking the cube root. What does the cube root mean again? Cube root means that whatever number is in here, we're looking for a number that multiplies against itself this many times. So cube root means 3. So a number that multiplies against itself 3 times and gives you, the circled number in here, that negative 8, right? So negative 2 would do the trick, right? Negative 2 times negative 2 times negative 2. Two negatives cancel, and notice that you're left with that one negative remaining, so we would get back that negative 8. So we know that this is true, and the same thing over here, right? We know that we have a positive 8 over here, positive 2, same exact idea. Positive 2 times positive 2 times positive 2, it's only positive numbers, and we notice that when we take the cube root of positive 8, we're just left with that same sign, right? It's still positive. So we go back over here to our actual question. And again, I posed to you guys the question, do we need the plus or minus? And we figured out, no, we do not need the plus or minus. So it's just y is equal to the cube root of 5 minus x squared. And now you realize when you plug in any number for x, doesn't matter what number you plug in, you're only going to get one particular value back, right? You're only going to get one specific number back. If you try plugging in 20 or 100 or a million, it doesn't matter. You're always just going to get one number back because taking the cube root of 5 minus whatever that number is means you're just going to get the cube root of whatever that number is. And then you just have that one sign, right? You don't have to worry about a plus or a minus. You're not going to get two answers. So we then can say, great, we can just replace y with f of x. And yeah, this is a function. So this is totally acceptable. So yep, this works out. So again, the directions asked you determine whether or not y can be written as a function of x, and in this case, yes, it can. Okay. This one was a little bit more tricky than the 3 before it. It'll maybe make more sense when we do, why don't we do question 15? I know nobody asked for it, but why don't we do question 15 first before we do question 20, just so that way this question and question 20 make a little bit more sense, okay? So 15 was like the most bare bones example that I could give of this. So 15 is we're starting with x plus y is equal to 2. And again, the idea here is we're trying to figure out whether or not y can be written as a function of x. X is our independent variable, y is our dependent variable, and we know that when we switch it to function notation, we take our dependent variable and make it into f of whatever our independent variable is. So f of x in this case. So once again, we're going to solve for y. So solving for y, we're subtracting x from both sides, which means we get y is equal to 2 minus x, or once again, you could have written it as negative x plus 2 on the right-hand side. Either way is acceptable. And now you just have to ask yourself, okay, well, if I plug in any value for x, any value at all, any number, will I get more than one answer back for y? So again, just for quick example, if I say x is equal to 7, well, that means I'm going to have y is equal to 2 minus 7, which 2 minus 7 is negative 5. And notice, we only get just the one particular value, negative 5. There's no positive 5. It's only negative 5. There's no other answers. There's no 3, 7, whatever the case may be. It's just y is equal to one particular value. And this should make sense because when we talked about functions, we always talked about, well, in the lecture video, we talked about how one input must map to one particular output, right? It's okay for this to happen, right? If I had this going on here, sorry, where these are, this is my input set and this is my output set over here. We know that this is totally okay. If we plugged in two different inputs, say for what somehow in some magical universe, if we plugged in x is equal to 3 and we still ended up with y is equal to -5, that'd be okay because our input is not repeating, right? If our input repeats and we get back another solution here, then we have a problem. So if we plugged in x is equal to 7 and we got something else other than -5 while also getting -5, then we have a problem and it's not a function, right? But notice that by plugging in one value, we get one value back. So this is in fact the function. So yeah, we can absolutely replace y with f of x and say, great, f of x is equal to 2 minus x. So yeah, this one works out. Okay? Any questions on this concept before we go on to question 20? I just want to make sure that we're all understanding what's really going on here. The idea is just that you're trying to just figure out whether plugging in one input gives you two or more answers. If it gives you two or more answers, it's not a function. It's purely a relation at that point. Okay, so I'm going to take it as you guys are okay, and then we're going to move on to question 20 here, okay? So question 20, same directions. So we're given x is equal to the absolute value of y. Okay, so x is equal to the absolute value of y. Well, to solve this, obviously we have to know our absolute value rules. So before we even deal with this, again, I'm just going to draw in blue over here. Let's think about an easier example. Instead of dealing with two variables, let's just deal with one variable. So say we had the absolute value of y is equal to 4. What did we know that this means? We knew that this means there's actually two solutions here, right? Because if you plugged in 4 for y, you would have the absolute value of 4 on the left-hand side, which just simplifies down to be 4 on the left-hand side, and 4 is equal to 4, right? That's a solution. However, you could also plug in, and I'll write this down, sorry about that. We know that that would work, right? However, there's also the other solution of -4, right? If we plug -4 in for y, and when we plug -4 in, we get the absolute value of -4, but that also simplifies down to be a +4, and that one also works out, right? So notice how we get two different solutions here with an absolute value, right? So now that we see how it works with one variable and a number, it's really just the absolute value of y is equal to 4. We know that this just turns out to be y is equal to plus or minus 4, right? That's what this simplifies down to be. And once again, this just comes down to our absolute value properties that we talked about before, going a couple chapters back. So if you need a refresher, start there. So coming back over here, when we have two variables, well, all that's happening is that the absolute value of y is now just on the right-hand side instead of the left, but we treat it the same way, right? So what this is really simplifying down to be is plus or minus x is equal to y. And now if you think about it, do we have unique solutions? If I plug in a number for x, am I going to get two or more answers for y? And the answer is yeah, right? If I plug in, 3 for x, well, that means that we're going to get +3, but we're also going to get -3 is equal to y, right? We get two different solutions. So because we're plugging in one input, and our one input is leading to two or more answers, two or more outputs, this is not a function. So you cannot write this in functional notation. Hence, yeah, this one does not work out. Are we following along with this? I know that this concept seems a little bit tricky at first. I just want to make sure that we're all good with this before we move on to the next chapter, which will be posted later today. It's important that we understand what a function really is before we continue on. So if you guys have questions, hit me with them now, so that way I can, see where there's difficulty going on.
I just have a question.
Yeah, sure.
For 15, the one that was x plus y equals 2, did you say that was just a relation, or could that be written as a function because it only has one output?
Oh, no, that's absolutely a function.
Okay, I just wanted
Absolutely.
to make
sure. Yep, I'm pretty sure I said it was a function, but if I didn't, yeah, good catch if I did not say that. But yes, it's absolutely a function. And again, just to rewrite it, or well, I'll keep this on the board for a quick second. But just to rewrite it, this is what we were dealing with number 15. We solved for y. We got y is equal to 2 minus x. And we saw that because we plug in any, value for x, it's just 2 minus that number. And we know that that's only going to give us one particular solution for one particular input. Yeah, this is absolutely a function. So yeah, we can write it like that. And that's okay. Okay? So yes, this one is a function. The x plus y is equal to 2. We can write that as a function of x. But we see here that this example, number 20, will actually not be a function because when we solve for y here, we notice that one particular value of x is actually going to give us two particular values for y, and that's not allowed for a function. Okay? Okay, so let's go ahead and clear this off. And Keji, you're asking for 33. Sure, we can do 33. I'm going to want, because there's a little bit to do here, I'm going to want some people to participate with this one. So let's at least get this going. So our function f of x is equal to 2x. That's an x. That's just made it worse. 2x over the square root of 4 minus x squared. Okay, so what you had to do is you had to find f at particular values, right? So the values ranged 0, 1, 2, -2, and then negative x, okay? So what you're doing is remember what that really means. The number that's inside that functional notation is your input, right? If f of 0, well, 0 is your x. 0 is the number that you're plugging in wherever that there is an x. So essentially what you're doing is you're just solving this equation. You're going to get some sort of output because you're putting in an input for x of 0. Okay? So let's see if I can get some participation. I don't know. Who haven't I called on in a while here? Let's see. Kayla, if you can help me out with f of 0, let's just do one at a time here. So plugging in f of 0, once again, this means that wherever that there's an x, we're plugging in 0. And then we're going to get some sort of output here. So help me first just by writing this out. Okay, so Kayla's not available. Sophia, if you're there, I would love if you could help me out with this.
Yes. Okay. So this is basically just completing the next step, right?
Yeah. So you're just writing out the right side of the equation when our input is 0. Again, our input is just we're replacing wherever there's an x with a 0, right?
Uh-huh. Yeah. So I'm just a little confused on this one.
Okay. So again, the idea here is 0 is what we're plugging in for x, right? And now notice.
Yeah.
Yeah, notice we have an x here, and we have an x right here, right? So all you're doing is you're just plugging in 0 in those locations, and then you're going to get some sort of output, right? Our input is 0, and we know that because, again, we have this notation, f of 0. So if our input is 0, we're going to get some sort of output by plugging in 0 for our x's. So we're going to get 2 times 0 here, and then do the denominator for me, Sophia.
Yeah, and then the square root of 4 minus 0 squared.
Yeah, 0 squared, and I'm just going to write it as 0 because we know that 0 squared is just 0, right? Okay, so help me simplify this. So what's 2 times 0? What's my numerator?
0.
Great. And then what is square root of 4 minus 0 in the bottom?
That would just be 2.
Yeah, square root of 4, and you would just get 2, right? And we didn't really touch on this too much. If you were worried about plus or minus here, again, unless you're solving for a variable, I told you guys this way back when we first started looking at square roots, unless you're solving for a variable, it's always assumed we're talking about the principal value of a square root, right? Principal, think positive, which means we're only considering the positive values here. So if we take the square root of 4, we're only going to look at just +2, not -2 here. Okay, so you don't have to write that plus or minus here. So we get 0 over 2, and we know that 0 divided by anything is just 0. So great. So when we plug in, our input is 0, and our output is also 0. And now, just extrapolating a little bit, we know that this would give us an ordered pair in the form of 0, 0. Again, we have our input, which is our x over here, and we have our output, which is our y. And that's it. Okay? So we see here that we can directly pull the information from functional notation into an ordered pair, which can be graphed. And that's really the whole point of functional notation, is that it allows for equations to be graphed a little bit more easily. That's the entire idea behind it. Now, obviously, there's more that goes to it, and we'll talk about that soon in the next upcoming lectures, but this is the first general idea behind it. Okay, so that was f of 0. So now we just have to keep on chugging, right? That was the first one. I think there were 4 more. So let's just keep going, and it would just be a miracle if my tablet would cooperate. There we go. Okay, so the next one that we have to do is f of 1, and I'm just going to do this one a little bit faster. So f of 1, once again, this means that wherever there's an x, we're plugging in our input. Our input in this case is 1, so that means we're going to have 2 times 1 up top, and on bottom, we're going to have 4 minus 1 squared, and 1 squared is also just 1, right? So I can just leave it as 4 minus 1. So 2 times 1 up top is 2. Square root of 4 minus 1 on the bottom is square root of 3. And if you have the textbook, most of the time, and also I will warn you, some professors are sticklers about this, me not so much unless I really specify it. They generally want you to rationalize such that the denominator is rationalized. Remember, rationalizing just means clearing the square roots, right? And if we remember how to rationalize, this just means I'm going to multiply the top and the bottom by square root of 3, and that's just going to be, oops, how do I move my equal sign? Magic. Okay, so that just gives us 2 square root of 3 up top. Square root of 3 times square root of 3 is the same thing as square root of 3 squared, which just gives us 3 on the bottom. Okay, so if you just ended with this 2 over square root of 3, that's totally acceptable. You know, you would have had no marks off. That's okay. It's just that if you were going by the textbook or some other stickler professors, they generally prefer you to have your final answer. So once again, your denominator is rationalized. So you would have 2 times square root of 3 up top over 3. And that would be your final answer, and probably what the textbook considers the correct. Okay. But either way, these are equivalent, and the only difference is just whether or not the denominator is rationalized. Okay, so that was f of 1. Now we have to do f of 2. So doing f of 2 over here, we are just doing the same thing, right? Rinse and repeat. So that means we have 2 times 2, and we have 4 minus 2 squared, right? Remember, don't drop the square. The only reason that I have been dropping the square is because we know that 0 squared is 0, and 1 squared is 1. Right? But now we see that we have a number that isn't 0 or 1, so I'm going to write that square. So let's go ahead and simplify this down. 2 times 2 up top gives me a 4, and on the bottom, I have 4 minus 2 squared. Well, 2 squared is 4, right? So we get square root of 4 minus 4, and continuing this, we get 4 over the square root of 0, and we all know the square root of 0 is just 0, right? So we get 4 over 0, and we say to ourselves, oh, yep, this is a problem, right? 4 over 0, you can't divide by 0, so no solutions, right? This is undefined. You can't divide by 0. You could just write undefined. You could write the empty set. Either way, this would be your answer for this one, okay? So we see that we're not always going to get a number when we plug in, when we plug something in. We saw that we got a number when we plugged 0 in, we got a number when we plugged 1 in, but when we plug 2 in, it's undefined. That just means that the function is not defined there. It means that the function just doesn't go there on the graph. So that means that, it cuts off at a certain place. If I were to just quickly show a quick example, your function very well could just start right here at this point and just do something weird, right? And then that just means that this entire area, which I'm going to label in red, this entire area is just undefined, right? So everything, to the left of that point just wouldn't work out. So as a result, you could result in undefined locations by plugging certain numbers into your function. Okay? So the point is we get an undefined answer. So that was f of 2. Now we have to plug in f of negative 2 and f of negative 2. Hopefully you guys are starting to see a pattern here, or at least recognize some sort of intuition. So we're going to get 2 times negative 2 up top. We have the square root of 4 minus negative 2 squared. And once again, we get negative 4 up top now instead of positive 4. But down here, we get square root of 4 minus, and now you just have to ask yourself, well, what's negative 2 squared? Well, negative 2 squared is the same thing as 2 squared, right? Because negative 2 times negative 2, you're going to have your two negatives cancel, right? So this is what's going on down here. We have negative 2 times negative 2. We know that those just cancel, and we would just get a 4, right? So we're just back left with the entire situation that we just had above, which is square root of 4 minus 4 on the bottom. And once again, we get negative 4 over 0. So we get a situation again where we have something undefined. So 2 doesn't work, and also negative 2 doesn't work. So now all we have left to test is f of negative x. That's the only last check. So f of negative x. What is that going to look like? Okay. Once again, notice how all we're doing is, when we're comparing it to the original here, we see that we have x's, and all we're doing is we're plugging in our input directly into the x's, right? That's been the entire game plan for the first 4 that we did. So if our input is negative x, that's not going to change our process at all whatsoever. Our input is just going to be negative x, and we're plugging in a negative x wherever there's an x. So essentially what that just means is wherever there's an x, we're just flipping the sign of it and seeing what happens. Okay? So f of negative x, well, that means we're going to have a 2 times negative x up top instead of 2 times a positive x, which is what we started with. And on the bottom, we have the square root of 4 minus negative x squared. Okay? Now we have 2 times negative x up top. So 2 times negative x, well, that's negative 2x. You can't really simplify that any further. On the bottom, you have square root of 4 minus negative x squared. But remember what we just talked about, right? This piece in particular that I just underlined, well, negative x squared is the same thing as x squared, right? Our negatives are going to cancel out. So that means we are just left with 4 minus x squared. And again, if you wanted to rationalize this, you absolutely could. You just rationalize it by multiplying, and I'll write it over here. You just multiply by square root of 4 minus x squared and square root of 4 minus x squared. But this is fairly unnecessary. I'm totally okay with you guys ending right here, saying this is your final answer. Okay? So just, all I want you to really get from this homework, this particular set of homeworks, is just understanding that you're not always going to get a defined value by plugging a number into a function. Okay, we very much still care about the domain of functions, right? The domain is a big recurring topic that comes up over and over again. And we see that, well, when we plug negative 2 in, negative 2 just happens to be outside of the domain of, this particular function. Same thing happened when we plugged 2 in. 2 is outside of the domain of this particular function. So we couldn't possibly plug those in and expect to get a number back. Whereas 1, and what was the other one that we did? 0. So 0 and 1 are definitely within the domain of this equation or this function. So we do expect to get a number back for those two. Okay? And that's really as simple as it is. Any questions on this before we move forward? Just want to make sure we're okay with this one as well. Again, the entire idea for finding f of whatever your input is you're just taking that input and plugging it in directly into that particular function. So if our function is f, we take our input and plug it into our function f, and then just solve as needed. Could we do question 42 as well? Sure, we could do 42. So yeah, I definitely wanted to do at least one of the domain questions, so I'm glad that we have enough time to do this. So 42, we're trying to find the domain of h of x. So again, we're trying to find the domain. You're not trying to solve. You're not trying to do anything, regarding inputs. You're just trying to find the domain. So finding the domain of h of x, well, we have h of x is equal to x minus 3 over x squared minus 4. Okay, Now you have to ask yourself two questions, right? And the two questions are, well, what are the two restrictions for domain? When we're talking about an equation, there's two restrictions that we care about so far, right? And I'm going to ask you guys, what are the two things that we can't have happen inside of an equation, no matter what? They're just not allowed for real numbers. Hopefully, at least one of them should be present here.
Wait, can you say that again, please?
Yeah, so when we're talking about domain, there's two restrictions for domain. One of them I'll give you guys a hint. One of them is for, yeah, exactly. Denominator can't be 0, right? That's our first one. So whenever we have a fraction, our denominator can't be 0. If it could possibly be 0, we have to figure out where it's 0, and then that's going to be excluded from the domain, right? So that's our first one. And then what's our second one? Which, for the record, is not present here, but it is present in 47. So maybe that gives you a bit of a hint.
The value under the even power root cannot be less than 0.
Exactly. The value underneath the even powered root cannot be negative, right? So we can't have a negative number underneath a square root, right? So again, just to really illustrate this, you can't have square root of -1, for example, right? This means nothing. This is absolute, this is garbage for real numbers. We define this in a special way. We call this I, right? We call it a complex number. But for real numbers, which is what we're concerned about, this doesn't do anything for us. So it's outside of the domain. So those are our two restrictions. So now we just ask ourselves, okay, well, given our two restrictions, what could happen here? Well, is there a square root? No, there's no square root. There's no even powered root. There's no square root, fourth root, sixth root, so on and so forth. So that's totally out. But we see we have a fraction, and our denominator involves our variable, right? So that means that we could potentially get a 0. So all you have to do is just figure out when the denominator could be 0. So you set your denominator equal to 0. X squared minus 4 is equal to 0. And I'm going to pick on somebody here because I expect everybody to know this, so I'm really hoping you know this. And Gabriella, since you were so vocal earlier, if you could just help me factor this. How do I factor x squared minus 4?
X plus 2, x minus 2.
Perfect, right? Difference of squares, x plus 2, x minus 2 is equal to 0. And we all know by zero product property, because we now have it factored, we can split them up, right? So we have x plus 2 is equal to 0, and x minus 2 is equal to 0. And that just means that our final solution, we get x is equal to -2 here, x is equal to +2. So at these two particular values, at when x is 2 and when x is -2, we get a 0 in the denominator, right? You can go ahead and try it. What happens if you plug 2 in for x? And, obviously the numerator is going to be some number. It doesn't really matter what that number is. But on the denominator, regardless whether you plug in 2 or -2, it gets squared, which means you're going to get a 4 minus 4 situation. And 4 minus 4 is equal to 0. And we see that at those two particular points, we get defined values, right? We're dividing by 0, and that's not acceptable. So these are the 2 points that we have to omit from our domain. So all other points are okay. If we had -3 or +3 or 1 or -1, those are all totally okay, right? Any other number is okay, except for -2 and 2. So can I get one last volunteer here today to help me write this in interval notation? How would I write my domain such that I'm excluding -2 and 2, but I want all the other points?
So would it be -infinity parentheses, and then -2 parentheses,
Perfect.
and then union parentheses 2, and then infinity parentheses?
Okay, so you're saying that, for example?
Yeah.
Okay, so you are 2/3 of the way there. So you have all the numbers to the left of -2. You have all the numbers to the right of 2. But what about a number like 0, for example? So what about the numbers between them?
Oh, okay. So it would be
So you're missing one last interval right in between them.
would it be -2 to 2 with parentheses?
Perfect.
Okay.
Exactly. And that's it, right? So what Aline was getting at is that we're talking about, we're excluding -2 and 2, right? So we're obviously going to be using parentheses around those numbers. And we always use parentheses for our infinities, right? Negative infinity, positive infinity, those always get parentheses no matter what the situation. So all we have left to figure out is, okay, how do we write all of the numbers that we want to include, right? So we're talking about all the possible negative numbers that go all the way up until we hit -2. So that's the first arrow. Then over here, we have all the possible numbers that are bigger than 2. So, that are greater than 2. And these are all going to be, 3, 4, 5, so on and so forth. But we also realize that there's numbers between -2 and 2 that also work. Again, -1 and 1 work. 0 works. All the fractions in between work, right? A half, negative a half, a third, negative a third, so on and so forth. And that's going to be our middle piece here. Okay, so don't forget to include all the numbers between them as well. And we see that we have 3 different intervals here, and this would be your final solution in interval notation for your domain. Any questions on this before we wrap it up today? I have one last announcement that I want to just real quick shout out there, but I just want to make sure there's no more questions on this. Okay, so if there's no more questions on this, again, just really reinforcing here that I will be sending out an email that depicts, again, everything that we talked about for the midterm in case you forgot. So you'll have that email on record for yourself. Of course, today's a Monday, right? And I'll be posting the lecture for today going into Wednesday. So be prepared for your next lecture. And the last important announcement is that I am feeling like really under the weather today. I actually would have canceled class today had it not been for the fact that this is the first class since the midterm, and I really wanted to deal with the midterm problem. So I wanted to sort that out before anything else. So today's office hours I am going to cancel because I just don't really feel up to it. I'll be honest with you. If you have any pressing issues or anything that you feel like could be handled in an email, feel free to reach out to me. Otherwise, I'll still have my office hours on Wednesday, and I'll see if maybe I can fit one in on Thursday if there's a demand for it. So I'll ask again on Wednesday if anybody wants another office hours this week, and if you do, then I'll try to fit one in on Thursday. Okay? Otherwise, that's it, guys. Thank you again for your patience with the midterm. Thank you again for attending class. I'm going to end the recording now. Enjoy the rest of your day, and I will see you guys next time.